artificial gravity, that is. You may ask, what is artificial gravity? Well, before you can answer that question, you first have to understand the basics of gravitational, centripetal, and centrifugal forces.
As I'm sure you all know, gravity is the universal attraction of one body of energy to another. It dictates how everything on Earth moves. From a bird in the sky to dropping a ball or jumping off the stairs. But wait, what if you're not on Earth, but in space? The same laws of physics apply, but just without the force of gravity. Artificial gravity can be created, however, using linear acceleration or centripetal force.
For example,
This video will solely describe centripetal force.
this time we're going to
Note the balls are still experiencing gravity and will fall out if the swing slows down. However, this demonstration illustrates an important concept that Shane will now explain.
So, the balls stay in the bottom of the bucket because the bottom of the bucket is continuously pushing the balls towards the center of the circle. As such, the balls stay in place throughout the entire motion. This concept can be applied in the future towards science when we build space stations so that we can have an artificial gravity that keeps the astronauts in place in space.
Thanks for the explanation, Shane. Let's now go to the library for a quiet atmosphere to further describe artificial gravity created by centripetal force.
The formula to calculate the centripetal force that was acting upon the balls in the bucket is centripetal force equals the mass times the centripetal acceleration, which means that we're really calculating the mass times the velocity squared divided by the radius. In the case of our buckets and the ball, if we want to calculate the centripetal force, we would say that the mass was 2 kilograms and they're being spun at a velocity of 2 meters per second squared over a distance of 2 meters for the radius. Now when we multiply the mass times the velocity squared, we get 8 kilogram meters per second squared divided by the 2 meters. Then, when we divide the 8 kilogram meters per second squared by the 2 meters, we find that 4 newtons of pressure were being placed upon the balls. In the case of futuristic science, if we wish to create artificial gravity on a space station, in order to know what speed to spin the space station at to create artificial gravity, we would have to solve the equation of velocity equals the square root of the radius of the space station times the gravity desired. As for our example of futuristic space travels, in the 1968 film 2001: A Space Odyssey, the spacecraft the Discovery 1 at a length of 140.1 meters, a width of 16.7 meters, and a height of 17 meters. This gives the Discovery a radius of 8.5. As such, it discovered the speed that the Discovery was spinning in order for the astronauts to feel their weight equivalent to the Earth. we would find that v equals the square root of 8.5 times the 9.8 meters per second squared, which would give us the final velocity of 9.13 meters per second in order for the astronauts to feel their weight equivalent to that of the Earth.